Hi, and welcome to Geometry. We're taking a look at section 7.2 today. We're going to start off with question number 16. We're given this interesting diagram. We are told that angle AFB is 70 degrees, arc ED is 120 degrees, arc AE is 80 degrees, and arc CD is 15 degrees. And we are asked to find the measure of arc BC. So let's go ahead here. We're looking for BC, and that's going to be this arc here. We can go ahead and start filling in with what we know. AFB is 70. I'm not sure if you can read that all. Compression might take that away. This is 70 degrees. AE is 80, not the angle, the arc. And that's an important distinction. ED 120, CD 15. Again, those are arcs, not angles. And what we need is BC. BEC is an inscribed angle, so we know that angle BEC is 1/2 arc BC, or 2 times angle BEC is arc BC. Now let's see here. Let's take a look at BEC. How are we going to find that? Well, I've got a thought. FEG is a triangle. There's 3 angles in here. Angle F, angle E, angle G. If we know all 3 of those, or if we know 2 of those, we can find the third. So our goal is to find angle EFG and angle FGE. That's what we're going to be trying to do. Angle GFE is vertical with angle AFB. So angle GFE, whoop, excuse me there, not GF3. GFE is vertical, measures the same as AFB, which measures 70 degrees. We were given that. So we've got one. We've got GFE. That's this guy. Got it. Next, FGE. Let's take a look at that. FGE is congruent to, it's vertical with CGD. FGE, let me enunciate that a little bit better, is vertical to angle CGD. This angle right here. So we find CGD, we found FGE. But what's CGD? We don't know. We just know that this arc is 15 degrees and then this arc over here is 80 degrees. That's what we're given. Well, we have a theorem for this. And we happen to know that angle CGD will be equal to, let me switch colors here, that's probably pretty terrible and unreadable. Angle CGD is going to be equal to half the sums of those arcs. So that's arc AE plus arc CD. It's half the sum of them. CGD is composed of 2 intersecting chords, AD, EC. They intersect at G. They're chords. They do not pass through the radius. They are lines whose endpoints do not pass through the radius. Excuse me. They are chords because their endpoints are on the circle. They intersect. The measure of either one of these vertical angles, CGD or AGE, is equal to 1/2 the sum of the arcs that they enclose. So that's AE and CD. That sum is 95 degrees. is equal to 1/2 95 degrees, so we get 47.5 degrees. That means the angle BEC, remember this is what we're looking for, BEC, which we said forms part of a triangle, BEC. That's this angle in the triangle right here. This one is 180 degrees minus this angle minus that angle. We know those two angles. 180 degrees minus the sum of GFE with FGE. And remember, we found those two. We found that they were 70 degrees and 47.5 degrees. So we are left with 62.5 degrees. And now, remember, we were looking for the arc. Not the angle, but the arc BC, which is twice angle BEC. So arc BC is 125 degrees. Yeah, lots of these problems are like that, including the next one. Section 7.2, number 18. Now, we're given a similar diagram to the previous problem, except what values we know are different. In this case, we happen to know that angle BEC is 71 degrees. We didn't know its measure the last time. We're also told that line segment EF is congruent to line segment EG. We know that the measure of arc AB is 18 degrees, and that arc AE is 3 times the length of arc CD. What we need to do, and this will be a long task, is to find the lengths of arc AE, arc CD, and arc ED. Lots of arcs. Well, I'm going to start with this congruency here. It's rather conspicuous to me. It tells me that we have an isosceles triangle here, and that's a very good thing. Triangle FEG is isosceles. And that means that these angles, EFG, EGF, are congruent. Okay. Because we have two congruent angles and we know the third angle in this triangle, we can find the measure of those angles. I know the measure of this angle. I know the length of this arc. We can use the previous theorem that we used in the last problem, number 16, the intersecting chords theorem, to find the length of ED. So, 180 degrees minus angle FEG, which is 180 degrees minus 71 degrees, that's 109 degrees. That's equal to 2 times angle EFG. Remember, EFG is congruent to FGE. So that means that angle EFG is half of 109, 54.5 degrees. Okay, now 54.5 degrees will be equal to 1/2 the sum of the arc lengths it intersects. That's AB, or 18 degrees, and arc ED, which we're interested in. Multiply by 2. 109 degrees is equal to 18 degrees plus ED. So Subtraction. 91 degrees is equal to ED. Excellent. We got one of them down. May as well mark it. It may come in handy. And we also know that these angles here, we found they were 54.5 degrees. Okay. Next, we need AE and we need CD. Let's take a look at AE. AE is 3 times CD. 54 degrees. That's this guy too. So, I'm going to use that previous intersecting chords theorem, this time with the chords AD and EC. And we know the angle AGE will be equal to 1/2 the sum of arcs. Let's see here, AGE, arc AE, and arc, hey look, CD. That's what we're looking for. Remember what we were given here? Yeah, we're going to use that now. I can replace AE with 3 times CD plus CD. That's going to be a grand total of 4 times the length of arc CD here times 1/2. That's 2 times the length of CD. And that's equal to our, angle, AGE. Oh wait, we know that. AGE, we know that. 54.5 degrees. It's the same as that previous angle we found. So arc CD is 1/2 that, which is 27.25 degrees, and then triple this is AE, and triple 27.25 is 81.75 degrees. Got it? Got it. Okay.